In this final unit, we're going to look at how to find volume of three-dimensional shapes. In this first lesson, we're going to look specifically at how to find the volume of prisms and cylinders. When we talk about volume, we're referring to how much something will hold. So we're trying to find the amount of space on the inside of this three-dimensional object in order to find out how much it will hold. As we think about volume, you might think about it if we were to take this yellow cube. Really what we're after is how many of those yellow cubes can we fit inside of each of these three-dimensional shapes. So if I were to begin to draw, how many of those yellow cubes would fit inside of this prism? And the same thing here with the cylinder. How many of those cubes can we fit inside of this cylinder? That's what volume is. And essentially when we find the volume of a prism or a cylinder, our formula is the area of the base times the height. So in order to put that formula into use, we have to be able to determine, well, what is the base of the shape and what is its height? Okay, that formula can be abbreviated as capital B, which stands for area of the base, times h, which is height. When we look at a prism and we are trying to determine what side is the base of this three-dimensional object, the important thing to consider is the base must have another base that is parallel to it. So as we look at this example, if I were to shade in the top of this prism, there is a bottom of this prism as well, right? That is parallel to that. So I could consider the top and the bottom to be my bases. Okay, but I could also say, well, you know what? The sides are parallel to one another. I could say that this side here is parallel to this side over here. Okay, I could consider the left and the right side of this prism to be the bases. But then someone might say, well, wait a minute, I believe that the front and the back of this are parallel as well. So if I were to take the front of this prism, it would be parallel to the back of this prism. So here's the thing, when we have a prism, we are going to find very often, especially if it's a rectangular prism or if it's a cube, that there are several sets of sides that are parallel. You pick what you want. So in order to do this example, I am going to use the two parallel sides that are the top and the bottom. Okay? You can choose the front and the back or the left and right side if you want, but I'm going to choose the top and the bottom. And so I'm going to find the area of that rectangle that is considered to be the top. So I'm going to draw just a clean image of that prism, one that I haven't written all over. That might be helpful to us as we continue working here. Okay, so I am going to use the front, I'm going to use the top and the bottom. So I'm going to go ahead and just shade those in just to remind us. I'm using the top and I'm using the bottom as my bases. Those two sides are parallel. To find the area of a rectangle, that formula is length times width. So the length of my base is 4.5, and the height of my base is 1.2. So in order to find the area, I'm just going to go ahead and grab a calculator, and I am going to multiply 4.5 times 1.2. And the answer to that is 5.4. Okay, so I'm going to plug that into my formula. The area of the base is 5.4. So to determine the volume, remember our formula is volume equals area of the base, which we just determined is 5.4, times the height. Okay, the height of a prism is the distance between the bases. Okay, the height is the distance between the bases. So remember, I chose the bases of the top and the bottom. So the height is going to be the distance between the two. This will be the height of my prism. That's the distance between the top and the bottom. So for me, the height is 3.5. So I'm going to plug in 3.5 to my formula. Now, to find the volume, I'm going to multiply 5.4 times 3.5, and I come up with a volume of 18.9. Now I need units. So my units is centimeters, and volume is cubed because I multiplied 3 dimensions. I multiplied a length and a width to get the area of the base, and then I multiplied by the height. So volume is considered as 3-dimensional, so it's 18.9 centimeters cubed. Now we have a cylinder. On a cylinder, it's much easier to find the bases. In the cylinder, there's only 2 parallel sides, right? It's the top circle, and then it's this circle on the bottom of the cylinder. Those 2 sides are the parallel sides in a cylinder, so those are my bases. Okay, so the circle is the base of my cylinder. Okay, those are the 2 parallel sides. I'm going to abbreviate parallel here with the symbol. Now, to find the area of a circle, the formula for a circle is pi times radius squared. So I'm going to multiply 3.14 times radius. Now, the radius is only halfway across the circle. So in this illustration, we've been given the distance all the way across is 40. So halfway across would be 20. Okay, so again, I'm going to grab my calculator and I'm going to multiply 3.14 times 20 squared. And that gives me 1,256. So I'm going to plug that into my formula. The area of my base is 1,256 times the height. Well, the height is the distance between the 2 bases. So here's the height. It's the distance from the top circle to the bottom circle. So the height is 46. I'm going to plug that into my formula, and I'm going to multiply 1,256 times 46, and my volume is 57,776 millimeters cubed. Now, here's another prism, right? This is not a cylinder. A cylinder has 2 circular bases. So this is a prism. Okay, remember, in order to find the base, I need to find 2 sides that are parallel. Okay, well, if you think about this, we have a left and a right side. Right here, this rectangle here, okay, that's a side. This larger rectangle over here is a side. If we consider, are those 2 sides parallel? No, because they touch right here at the top. So those 2 sides aren't parallel. Let's consider the bottom. Okay, that piece that I'm kind of dotting as I fill in, is that parallel to anything? No, because there's not a top side. So in this prism, we only have 2 sides that we can consider to be parallel. And that's the triangle in the front and the triangle in the back of this prism. This is called a triangular prism because the bases are triangles. The only 2 sides of this prism that are parallel are the 2 triangles. So those are going to be my bases. So what I'm going to do is I'm going to find the area of one of these triangles. To find the area of a triangle, that formula is 1/2 times base times height. So my triangle measurements that I've been given in the original diagram, the base is 4 and the height is 3. So I'm going to multiply 1/2 times 4, that's 2. 2 times 3 is 6. So I'm going to fill that into my formula. The area of my base triangle is 6. Now I need to multiply times the height. Well, let's think here. The distance between the 2 bases is my height. So the distance from this triangle to this triangle is 7 meters. So my height is 7 meters. I'm going to fill that into the formula. Now my volume is 6 times 7, which is 42 So my final volume is going to be 42 meters cubed. As you listen to these examples, I found the area of several shapes. I found a circle, I found a triangle, I found a rectangle. You may have forgotten some of those formulas. If you have, in lesson 8.1, at the very top of the lesson in the teacher's introduction, there is a PDF that you may download and put into Notability that contains all that possible area formulas that you may need as we move through this short unit. I'd encourage you to go ahead and download that PDF. You may even want to go as far as making a note card to just use in class with you as you work practice problems, as you work your checkpoints. It might be easier just to have a note card to keep on your desk. If you would like to do that, you are more than welcome to do that.